Hi, science teachers. Welcome to Real Science Challenge. I'm Kent Louie, teaching science and broadcasting from beautiful Vancouver, Canada. Thanks for doing an awesome job teaching your students. Now, today is another episode of EdLab, where I share something I'm trying with my science classes so that my students can learn science more effectively. Now, today I'm talking about proficiency scales and one way I'm using them in my classroom. In short, proficiency scales do take more time at the onset. However, looking at the big picture, I believe proficiency scales do a better job at furthering what our students need to do as scientists and where we can help them, especially once students and teachers know what to look for. Now, if you've used or are using proficiency scales, please let me know how you're using them in the comment section below. Handouts for this episode are available at realsciencechallenge.com EP14 and subscribe to our YouTube channel. So here's some background information. A few years ago, BC changed or revised their science curriculum and had science teachers now report what science skills students can do, as opposed to, memorizing a whole bunch of facts. These skills were known collectively as curricular competencies, like planning and conducting experiments, analyzing, processing data, evaluating methods, communicating scientific conclusions, all that stuff we teach students. Now, this is not just a thing in BC. I know states and provinces and other countries do the same thing. Now, when we report on skills, we use a 4-level proficiency scale, here known as emerging, developing, proficient, and extending. And I know that other provinces and states use different language or labels, but for the purposes of this video today, I'm going to use those 4 levels. Emerging being the most basic, developing, proficient, and extending. The struggle for teachers is, what do these proficiency levels, emerging, developing, proficient, and extending, what do these proficiency levels look like? And how can we use it in the science classroom? Now, in general, I tell my students I use the proficiency scales to mark for sophistication, depth, complexity of thought in their answers. For example, when answering a question, a student at the emerging level may provide a very vague, overly simplistic answer. A student at the developing level may provide a partial answer, while proficient and extending students tend to provide complete and sophisticated answers, respectively. Now, that probably sounds pretty simple to understand, perhaps overly simplistic. So what does this actually look like in specific examples? So in one of my most recent quizzes, I used proficiency scales to mark it. Here it is. Those are my categories. Those are my curricular competencies. And of course, those are my levels. And no joke, it took me 2 weeks to mark it. So yes, proficiency scales do take more time at the onset, but out of it came a better idea of what my students were struggling with. Now, one of these questions had something to do with planning and conducting an experiment. Specifically, assume you're a scientist testing whether or not a metal supplement made of molybdenum, scandium, yttrium, or zirconium, is actually helpful to your body. Describe how you would set up a fair test that would help you find the answer. Now let's talk about how I broke down these proficiency scales for this question. Now, an emerging student would have provided a very basic experiment. Basically, take the pill and measure to see if there's any benefits. Overly simplistic, overly vague. A level 2 or developing student would have provided perhaps a comparison, an experiment where they compared before and after. For example, measure how you feel before an experiment and then take the pills and then measure how you feel after the experiment to see if there's any health benefits. A complete or proficient experiment would have mentioned more controls, more controlled variables. They would they would have talked about comparing the results of the metal you're testing to perhaps a placebo, so that you can actually see if the metal does anything, the supplements does anything compared to a control. And an extending or level 4 answer would have perhaps gone beyond that and developed an experiment to see if how different metals ranked against each other for effectiveness, while at the same time comparing to a control group. Now let's provide some samples from my students and what they wrote. Here is an emerging response. First, choose which are foods that include these elements, or maybe foods that only include one element for each. Eat one of them and eat another one next week. Test blood during the days after eating them. After a day eating them. That's literally what it says. Again, this is an emerging response. Very, very vague. Not a lot of controls. Not a lot of comparisons to before and after. So a very general, very basic response. Now, unfortunately, none of my students actually had an extending response. And that's perfectly fine, because we're going to build up to that throughout the term. But at least I know where the students are and what we kind of have to work on throughout the term to get them to that extending level. That's it for this episode. Thanks for watching, and remember to science everywhere, every day.